Hi everybody! In this lesson, we will learn how to create a circuit by adding a resistor in order to protect the LED. We already learned that the digital pins from 0 to 13 provides 5 volts, and those pins are controlled by the Arduino software. I mean, you can write a program to turn off and on an LED and changing the duration of this blinking. What you should learn in this lesson is that the LED cannot support 5 volts for a long duration. I guess you learned this in the electricity chapter in physics. In order to simplify the task, I will ask you to go on Google and check for how many volts the LED supports. Look at the result. It shows that the value is between 1.8 and 3.3 volts. In order to know which value of resistor we should use to protect the LED, go on Google and check for the value of the resistor in order to protect an LED. Look at the result. The resistor value must be at least 183.3 ohms. Once we know that the value of the resistor should be at least 183 ohms, we will proceed to measure the resistors we have by using the ohm meter. Look how I set the ohm meter to the appropriate value. Then I start measuring the resistors I have in order to fix the one that correspond to the nearest value of 183 ohms. Since the 220 ohm resistor is selected, since it is the nearest value to 183 ohms, I will proceed by showing you how to build the circuit using the fritzing software, and then I will show you the project in real. In the fritzing program, I have my Arduino board and my breadboard. Look how I build my circuit without the resistor. It is going to be like a review of the previous lesson. Using a jumper wire, I connect the ground pin to the first pin of the breadboard as shown. Using another jumper wire, I connect the digital pin number 5 to one of the pin of the vertical columns as shown. I select an LED and I insert it on the breadboard. I use a jumper wire to connect a ground pin to the cathode lead of the LED. So this is the normal circuit of an LED without a resistor. Now comes the time to integrate the resistor on the circuit. I move the jumper wire that connects the digital pin 5 to another column on the breadboard, as shown on the screen. I insert the resistor on the breadboard as shown. One side on the same column as the anode lead of the LED, and the other side to a pin on a new column where the jumper wire of digital pin 5 will be connected. So now, as you can see, the digital pin 5 that provides 5 volts will pass the current via the resistor of 220 ohms to the anode lead, and as a result, the current will be between 1.8 and 3.3 volts to the LED. Regarding the program, as you can see, it is the same as the one we created in the previous lesson. Nothing changed even by adding the resistor. I will upload it to see how the LED will blink. Now it is your turn to create the same circuit and to add 2 LED instead of 1 in order to control their blinking. And of course, you should not forget to add 2 resistors in order to protect the LED. Thank you for watching this tutorial, and do not forget to follow us on YouTube, Facebook, and Instagram in order to access to additional educational resources.